Hey everybody, welcome to chapter 2, atoms, molecules, and ions. So now we're going to talk about those little particles that make up all matter. Okay. The theory of molecules came from this crazy looking dude right here. This is John Dalton. He was a chemistry teacher, so you know he had to be brilliant. But anyway, Dalton came up with what they call the atomic theory. Now he didn't he didn't invent any of these, but what he did was he took all the information from other scientists and he put it all together. Okay. So the first thing he said was that all matter is made out of atoms. They're the building blocks of all matter. So John Dalton is the one that gets credit for writing his atomic theory. And what's really cool about what he said in the early 19th century here really hasn't been proven wrong today. So he was kind of a guy before his time. All right, so he said each element is composed of really, really tiny particles called atoms, which is true. He also said that atoms are identical to one another. He said in mass, and that changes a little with isotopes, but the properties are all the same. So in other words, if you have an atom of hydrogen, all atoms of hydrogen are the same. If you have an atom of nitrogen, all nitrogen atoms are the same, but if you compare a nitrogen to a hydrogen, they're not. They each have their individual characteristics. So basically, he said atoms of the same element have the same properties, but if you go to an atom of a different element, it has different properties. Okay. Atoms of an element are not changed into different elements. So you can't take them and change them by doing stuff. Instead, what you do is you combine them in chemical reactions. Really what he's saying is you can't destroy matter, which we actually figured out a way to do. They added this to his in chemical reactions. See, in nuclear reactions, we actually can destroy matter. But that was way before his time. There's no nuclear bombs and all that. So what he said was right as long as you leave the chemical reactions in there. Okay, so atoms cannot be created or destroyed. You just change them by reacting them. And again, that's something that was very important because it's true. It hasn't been proven wrong unless you're talking about nuclear reactions. And then he said atoms can combine. You're looking here, we take a nitrogen and an oxygen and put them together, and we have nitrogen monoxide. So you can make compounds. And when you make a compound, it has the same atoms and the same number. So in other words, water is H2O. You always have 2 hydrogen and 1 oxygen. If you don't have 2 hydrogen and 1 oxygen, it's not water. Okay? So there's some other things that came out of his work. One of them is the law of conservation of mass. Okay? And what it's really saying is the total mass of substances in a chemical process, what you start with and what you end with is the same amounts. All right? So if you start with 20 grams of oxygen and 20 grams of hydrogen, and they go through a process and they produce water, it should be 40 grams. All right. The process, you end up with the same amount. And there's a lot of things that we do in chemistry because of this law, like we balance equations and things like that. So this was one of the laws that came out of Dalton's theory. There's another one called the law of multiple proportions. Okay, if you have 2 elements, let's say you have element A and B, and they form a compound, the masses of B that combine with A are always in the same whole number ratios. And that's what I was saying like with water, okay? Water, the proportion is 2 to 1 of hydrogen to oxygen. But hydrogen only has a mass of 1, so there's 2 grams of hydrogen to every 16 grams of oxygen. If you want to reduce that to 1 to 8, you can. But that 1 to 8 ratio is always what it is of hydrogen to oxygen and water. If you change that, let's say you go to H2O2, which is hydrogen peroxide. Now you've changed the mass. It's 2 to 32, so now it's 1 to 16 for the ratio. That's not water anymore. And really, besides the fact that they're liquids and they're colorless, there's no other thing about hydrogen peroxide and water that are similar. If you're thirsty, you do not want to take a big swig of hydrogen peroxide. Okay? So they have, different properties. They're different. You can have the multiple proportions, H2O2 to H2O, but if you don't have them in the same proportion, they're a different compound with different properties. Okay, so the other thing that Dalton didn't know about, he said we have these subatomic particles. We have these little, these little atoms and molecules, but he didn't know that they actually made up of little parts as well. So there was other scientists that started working on their structures, okay? Electrons, and I'll show you that experiment, how they figured out there's electrons through cathode ray tubes. Radioactivity, the decay. We have the nucleus, we have protons, we have neutrons. All these things were discovered by other people. Dalton didn't know about them, but his atomic theory about things being made out of atoms, and atoms are the same for each element, and you can combine atoms to make new substances, was all, spot on. Smart guy. Okay? So here's how they discovered the electron. The electrons are on the very outside of the atom. They're like if you think of the atom as like a solar system, the nucleus is the sun, and then all the planets orbiting, those would be electrons. Give you a visual, I guess, if you want to put it that way. But the guy that figured out that there's these particles on the outside, his name was J.J. Thomson. No P. Thomson. I don't know. Anyway, he discovered it in 1897. And what he did was, here's a cathode ray tube. When you charge it, you have this, flow of electrons. Well, then what he found out is when he takes a magnet, he can change that flow. So he knew that there was something going on there. There had to be some charged particles, because why would they change their path if they were neutral? They wouldn't be attracted. So he's the one that figured out, he's the one that gets credit for discovering the electron. Okay. He also measured the charge and the mass ratio of the electron. Again, using an electron tube and how much it deflected it. And you can see there's the anode and the cathode. The anode is the positive electrode, and the cathode is the negative. And they get this charge going. So you have this flow of negative charges going. Why is it, how much does it get deflected? He used that to calculate the charge and the mass of an electron. And he found that the mass of electron to be really, 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 really small. Okay. There was another guy by the name of Millikan. And what he did was he figured out the actual charge of the electron. And you can use his experiment to figure the charge or the mass. But he used oil drops, and they were funneled through a hole. He had an X-ray. So what he did was he looked at it microscopically, and then you can see he has a little charged particle. Which way did they go? You can see the source. And they ended up going this way, so he knew. And all these experiments are kind of a way, because we can't see the electrons. So it's a way of figuring things out without actually seeing them. You're using the knowledge that you already have to figure out things about atoms, because at that time, there was no way we had a microscope that was good enough to see them. So they used other ways of figuring out information about it. So he's the one that determined the charge of electron, 1909. So Thomson discovered there's electrons in 1897. 12 years later, they figured out the actual charge. Okay. There's also radioactivity when you come to atoms. They will actually break down, not all of them. If you look on a periodic table, it'll tell you the ones that are radioactive. And what that means is they can decay their nucleus. Their inside can break down into gamma rays and beta and stuff like that. And they use that a lot in medicines and things like that. But not all elements are radioactive. Okay. And again, I think Henri, which he's a French guy, so it's not Henry, Henri, he's the one that discovered this, and I think the unit for radioactivity is named after him. Okay. Also, Marie and Pierre Curie, they studied radioactivity. The problem with them, her especially, is they did all this study in radioactivity, and they didn't realize it wasn't so good for you, and she ended up dying of cancer because of all of her work with radioactivity. Okay. But they discovered how the atom has subatomic particles. So the atom is the smallest, unit, but if you take that unit and you look into it, you have particles, and we call them electrons, protons, and neutrons. Okay. Another guy that discovered part of it was Ernst. You gotta like that name, Ernst Rutherford. He's the one that figured out that there was a nucleus. And what he did was he passed a charge through gold foil. And he said, well, now if the electrons are all scattered, it should just all pass through. But what he found out was sometimes they were reflected back. And so he knew there had to be like a dense part of the atom somewhere. And through more research, he figured out it's right in the middle. So this is what they thought an atom look like. They call it the plum pudding model. And Thomson, the guy that discovered the electron, came up with it. He said it's just like this gelatinous blob, and you have the electrons kind of scattered, and then you have the protons kind of scattered. So there was no real organization to it. And this is, 1900. This is what they thought the atom looked like. Well, then when you did Rutherford, when good old Ernst, he shot these particles through the gold foil. Now, if it was the plum pudding, all these atoms in the gold, they should have just shot straight through because they're all scattered. But what he found out is some went through, but some of them got deflected. And so because they got deflected, he knew there had to be in the atoms a dense part and a not so dense part. Okay, if it hit the not so dense, it went straight through. But what about these ones that are getting reflected? So he's the one that gets the credit for the discovery of nucleus, that there was this dense portion in the middle. Okay, so here's his interpretation. Like I said, some of them went straight through, some got deflected a little, some got deflected a lot. So he knew that Thomson's model wasn't correct, that they weren't scattered, that there was actually an organized, dense middle, and they call that the nucleus. Okay, and so he said, again, Rutherford is the one that gets credit for the discovery of nucleus. He didn't know that it was protons and neutrons. He just knew that there was this dense part, and it had to be made up of some more different particles, not electrons. The other thing he figured out is because most of them went right through, then most of an atom is just empty space. Okay, so, and they're very, 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 very small. Tiny, 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 tiny. Okay, so later on, there was guys that discovered that this nucleus was made out of protons and neutrons. Chadwick is the one that gets credit for the neutron. Okay, so we have 3 subatomic particles. We have protons, which have a positive 1 charge, and electrons, which have a negative 1 charge. And when you have an atom, these two equal each other, because an atom doesn't have an overall charge. So if you have 25 positive, you have to have 25 negative. So they're neutral. And then a neutron doesn't even have a charge. Basically what a neutron is, just gives it some mass. Okay, if you want to figure out the mass of electron, you take the protons and the neutrons and you add them together. So the mass of the electron is so tiny, they just ignore it. It's just too small to even figure into it. So proton is positive and its mass is basically 1. A neutron is negative and its mass is generally 1. And those two are found in the nucleus. So there's your dense. And then around the atom, you have this big cloud of electrons, which they are so tiny, they don't even figure into the mass. So if you want to figure out the mass, add these two guys together. If you want to figure out the charges, these two have to equal each other, because neutrons don't have a charge, but protons and electrons do. So whatever the proton charge is, the electron charge has to equal it. Okay, so protons and neutrons are found in the nucleus. Electrons are traveling around the nucleus. Okay, so if you're trying to figure out what an atom weighs, again, it's a relative unit. If you look at it, it says AMU, atomic mass units. They had to kind of bump it up so it made sense so that we could actually measure it, but it's pretty tiny. So, here's the heaviest atom is, you take point and then write 21 zeros and a 4. That's the heaviest atom known. So obviously that's not a scale we can work with. So they came up with a relative scale so we could work with the units. Okay, so we have the AMU is the base unit, atomic mass units. We kind of bumped it up to grams, and we'll talk more about how many units that is later, but that's the way they made the scale so we could actually use it. Okay, and again, you can see that it's a pretty small unit. When we're measuring the atomic mass, again, they used a lot of cathode ray tubes, and to separate them, this is how they measured it for greater accuracy. They used a mass spectrometer. And again, to figure out this stuff, because they're so tiny, they had to use some pretty fancy equipment. Okay, but the way they based it on was carbon-12, because that's one of the most common substances. So carbon-12, they basically added the protons and the neutrons together, and that gave you the mass. So when you see C, that means carbon, and then the 12 is the numbers added together. Okay, we'll quit here because I'm just about running out of time. I'm just about at my 15 minutes. So again, the structure of the atom was a lot of scientists working together. They all discovered different parts, and then they put it together to give you an idea of what an atom is made out of. Okay, so so much for part one, and make sure you do your assignment at the end of the chapter.